Alright guys, welcome back to the final VOD for Unit 3, okay? Today we're going to be discussing substances, compounds, and mixtures, alright? So today we're going to learn to differentiate between what exactly is an element, what's a compound, and what is it when they're kind of together, and how are they different from one another, okay? So lots of vital information here, stuff that's going to help us when we get into chemical reactions next unit, okay? So sit tight and let's get through this, okay? First of all, we have the elements, all right? The elements are the things that are on the periodic table that we've discussed in class, okay? We've drilled those in by now. And as you should be aware, okay, they can exist as solids, liquids, or gases, right? The states of matter, okay? Now, every element on the periodic table can exist as in one of these states depending on what temperature it is, okay? They all have different boiling points and melting points, right? Which was a physical property. Don't forget that either, okay? They do consist of only one type of atom, elements and substances do, okay? So that means that they are made up of strictly one thing, okay? Some of them are like two of themselves, like hydrogen, hydrogen, fluorine, bromine, iodine, etc. Okay, there's a stack in there that I'll show you that actually exist what's called diatomically, which means in twos, okay, in pairs of themselves. But they are pure elements, okay? They consist of only one thing. And this is how they appear in nature, all right? The next thing is going to be a mixture, okay? That's when you take two substances and put them together, okay? You don't react them chemically, you just have them sitting close to one another, okay? So a mixture is something like brownie batter, like you see in the first picture, okay? Or it's something like the trail mix that you see in the lower picture, all right? Now, the brownie batter is what's called a homogeneous mixture, okay? So that means that it's homogeneously put together and you can't tell the different parts, okay? In a homogeneous mixture, you can't see the different pieces. Now, in a heterogeneous mixture, you can see the different pieces, all right? So in our trail mix, you can see there's chocolate chips, butterscotch chips, white chocolate chips, peanuts, all that other kind of stuff in that trail mix. But in the brownie batter, you can't see the eggs and powder that went into making it. Does that make sense? So think about Kool-Aid, okay? Kool-Aid is another example of a mixture. Oh yeah, right? So the Kool-Aid is actually a homogeneous mixture, okay? Unless you let it sit there for too long. In that case, the sugar dissipates and gets down at the bottom, and then you actually can notice it. But in a homogeneous mixture, you can't see the difference, okay? It all looks as one. Now, that brings us to the last one of these, which is compounds, okay? Now, compounds are using multiple atoms on the periodic table, okay? So different elements come together to make a compound. They are, however, chemically tied to one another, okay? In the case of a mixture, they were chemically separated, okay? This was, say, iron, and this one was, say, sulfur. You just placed them together. You didn't react them in any way. They're just in one pile, okay? Now, in a compound, you've reacted them in a certain way so that they are stuck together, okay? And it takes energy to either break them or make them, all right? So compounds consist of two or more atoms joined together by electrons, all right? Now we can share these electrons in what's called a covalent bond, like what happens in sugars, okay? Or even in ammonia. But we can also have what's called ionic bonding, which occurs in salts, okay? Salt, sodium, chloride, right? That's where a sodium ion is bound with a chlorine ion, okay? Cation, anion come together, plus and minus, opposites attract. They come together and form a compound, okay? They're linked together by difference of charge. But in a covalent bond, we share them, all right? They share their electrons. So in this picture that you see of the sugar, okay, remember I kind of got into this once upon a time during class that each one of these corners is a carbon molecule. But you can see that the oxygen is sharing. It's even easier to see with this ammonia, right? Nitrogen has 5 valence electrons, okay? Hydrogen has 1. Now, when you see one of these bars, that indicates a covalent bond, which means that they're sharing that electron. Does that make sense? So all the hydrogens have a satisfied octet now, and so does the nitrogen. They all have 8, or 2 in hydrogen's case, in their valence shells. Now, we'll explain this a lot more in depth in class. But it's important that you understand the difference between what an ionic compound is and a covalent compound is, okay? Ionic is due to a difference in charge. Covalent is due to sharing, okay? Now, what on the periodic table will form covalent and ionic compounds, okay? Metals and nonmetals are your winners for forming ionic compounds, okay? The metals will willingly give up electrons, whereas the nonmetals will willingly take them on, okay, except for the noble gases. So think about sodium and fluorine, okay? Sodium has a valence electron shell with 1 electron, okay? Fluorine has a valence electron shell with 7, okay? The sodium will willingly give up that electron, and fluorine will willingly take it on, okay? Easy. So they both want to have the octet, right? The full octet to be like the noble gases. So again, the metal will give up the electron and the nonmetal will take it on, okay? Now, in covalent compounds, we have nonmetals and nonmetals bonding with one another. So that means that the right side of the periodic table is the only ones that can act to form covalent compounds. Now, multiple examples of covalent compounds exist in nature, all right? There's things like oxygen, nitrogen, we have sulfur monoxide, carbon dioxide, okay? We have all types of different nonmetals that are bound together by sharing their electrons, okay? Water is an example of a covalent compound, okay? The hydrogen atoms and the oxygen atoms share their electrons to form a compound, okay? But, okay, you need to make sure you understand metals and nonmetals are ionic. Covalent is only going to form when it's a nonmetal and a nonmetal, okay? They have to be the same in that case. You can't have two metals bond together in this instance, all right? Metals can't bond with metals to form covalent bonds. Metals are only going to participate in ionic bonding. Okay, so make sure you understand the difference between what will form what types of bonds on the periodic table. That's one of your student expectations, things that I expect from you from this unit, okay? It's actually tested. So check your notes on this. Make sure you're good to go for the flipping quiz next time. If you have any questions, once again, come in for activity period. We'll get it done, all right? Appreciate you guys. Y'all have a good evening.